All right.
And if you restrict make your business so tightly down that somebody has to go insecure to go between the two, good. And if they want to be in common, it's a long-term situation that doesn't work, and you don't have to accommodate it.
All right. Okay. That's your position. All right. So we'll talk about the mic some more.
Oh, we'll talk about
And afterward, I'm going to sit down and have a long later. Yeah, I know. So it's like, did you read the draft?
So, good morning. This is the DNSOP session, the second session on Friday. If everybody can take their seat. Thank you. So, welcome to the DNSOP. My name is Benno. Andre is my co-chair. And in front, the secretary, Shumon and Peter, are sitting over there. Jim Reed is our technical advisor. And our area director is Matt Boucader. You can find for online participation, you see the Meet Echo and the on-site tool. And the minute taker is Paul Hoffman. Yeah, okay, thanks. Everybody's in the room. Next slide. This is the Node Well. We expect you to be knowledgeable about the Node Well. I've read it, or at least get a gist of it. It's important, especially this one, the code of conduct. I repeat it again. If anybody feels it's improperly addressed, please contact the DNSOP chairs. We take this seriously. Good. The meeting tips, please register via the on-site tool or the full client, because your name is put down in the blue sheets, which is important, a part of our IETF process and the Node Well. Right, go fast forward. The agenda. So before we go to the agenda, I want to mention one thing. In the past weeks, we received a lot of requests for call for adoption. And as you might know, have read on the mailing list, we only could accommodate 2/3 of the agenda requests for this week. There's a lot of work coming towards the DNSOP working group, so we have to make decisions. We explain our decision, but we also want to mention that we will look into the call for adoptions, make some deliberations, and share that on the mailing list, because it's too much work to digest at once. So we have to plan and balance the work we take up in our working group. Thank you.
And without further ado, so we have, for decision, we have 9 drafts for consideration. I don't think it makes sense to just read them here aloud. I think you can look up them in the agenda. So it would be better to just start, because the agenda is packed, and the first presentation is best practices for persistent references in DNS.
There we go. Yeah.
Sure.
Thank you.
Hello, everyone. I'm Andrew Kazer, presenting our draft today, Best Practices for Persistent References in DNS. So what does this document target? It is targeted at application service providers who provide or rely on associations between a global DNS domain name and use case specific persistent references. We'll see some examples on the next slide, but at a high level, we're proposing in the 0.0 version of this draft the use of DNSSEC to provide a globally consistent, cryptographically verifiable association, which is important, especially for scenarios where there are multiple application service providers involved, in which case non-space DCV may not be practical, because if a user has to go and validate control of a domain name at dozens or possibly hundreds of application service providers, it quickly becomes infeasible. So what are some of these examples? Well, examples of persistent references as we have defined them in this draft are pretty broad ranging. They include things like CAA records, wallet addresses, and social media handles. And rather than walking through each of these in detail on the slide, I'm just going to point out a few points here about what persistent references entail. One thing you'll notice is that the R data in these fields are not random nonces. They have intrinsic value to the use cases in question. So if you're a wallet address and you see coin1, address 1, and you're using the wallet RR type, you know what to do with that information. And another point here is that they're persistent in the sense that as long as they are here, application service providers can use them. If they are removed from the zone for whatever reason, providers should relatively quickly, ideally, cease using them. And it's important to note that in many of these cases, there are in fact multiple application service providers. CAA, there's dozens of certificate authorities, wallet addresses, each individual wallet may be considered a service provider, and so on. Now, one thing you might be wondering is, how does this compare with the DCV BCP draft currently working its way through DNSOP? Well, when we originally released this 0.0, there was more space between those two drafts, but in the recent weeks, the revisions and the discussion on the mailing list make us think that they're actually closer together than they were just a couple weeks ago. And I'll just point out a few differences here and why we think that now they're actually not so different. So in one case here, record content and persistent references is use case specific data. The DCV draft currently uses random nonces. Now that seems like a pretty big difference, but there's discussion occurring to use unique tokens instead of random nonces. And if unique tokens are used, we believe that would cover most of the record content use case specific data in our draft. In our initial version of the draft, DNSSEC was a must. We received feedback that it should look more like what was actually being discussed on the DNSOP mailing list after Monday's session, where users should use DNSSEC, but validators and application service providers must validate it, DNSSEC if it is present. This is important for us that that occurs because users who opt into DNSSEC should be able to continue to have that security guarantee. And then those who do not opt in will be able to still be able to use the application's use cases. Periodic revalidation is a must in our draft. It's very important that these applications don't just grab the record one time and then use it forever. Domains expire, they can be transferred, you might change your zone. So it's important that application service providers have some process in place to ensure that they periodically recheck these records. In DCV, it's sort of up to the application service provider in earlier versions of the draft. In the latest version, though, their discussion on persistent validation more or less covers our use cases and provides good guidance on what would also apply to persistent references. So where does that put us for next steps? Now, this type of use case is becoming more common, so we do want to provide guidance on how to do it safely and reliably. And how can we achieve this guidance? Well, we've already had conversations with the DCV PCP co-authors, and they're open to including many of these topics in their draft. And we think that would be great because that can get this guidance out in the nearer term rather than having an independent draft that might take several years to get this guidance out the door. But of course, pursuing as a standalone draft is also an option. So we would be interested in hearing your feedback. Thank you.
Okay. Anyone in the queue? Questions, suggestions? Yes. Schumann.
Hi, Andrew. So I see Eric in the queue behind me, so perhaps we're going to say the same thing. So I know you know, but I just wanted to mention for the working group that we did have a discussion this week about kind of the deltas between our two drafts. And you're right, they are closer. I think we have to work out still a few more details, but depending on the outcome of those discussions, it's possible we could converge. And just to clarify, by DNSSEC mandatory, you mean if the zone is signed, then the validator must validate, right?
Yes.
It's not because if you say DNSSEC has to be present everywhere, that's too high a bar, right? That's not achievable in the practical.
In the version 0.0 of our draft, we had that very high bar.
Okay.
We were moving in the direction based on feedback we received, essentially what's already been discussed on the mailing list with the DCV draft, that the language I believe Eric proposed on the mailing list looks like it was pretty close to what we think would also be appropriate here.
Great, thanks.
Yep, thanks, Shuman.
Thank you.
Yeah, Eric Nygren, most of what Shuman said. I think hopefully we can work and see if we can converge them. I think there are some things that are that we may want to still have a separate draft for anyways for the things that aren't best current practices. So for example, the multi-account stuff is one that we pulled out of the DCV draft because it's not widely used enough to be a best current practice. But I think we could fold we can create a separate draft for that covers both the one-off and persistent validation use cases subsequently.
All right, thanks, Eric.
Yeah. So it's for the people here on stage, very difficult to see the room. So if we look in the wrong direction, please excuse us. Okay. No more questions? Thank you. Thank you very much. Next is Peter.
Okay, the deck is being shared.
All right. Yeah, on one screen it is over there. But
I mean, I can't see it, so.
Okay, I try it again. 1 moment.
Ah, it's moving.
Or you can.
Okay, yeah, that's good enough. Yeah.
Can you
Okay.
try the clicker?
Thank you. Okay, so a few months back, I've posted a draft on operational recommendations for DS automation on the list. I'd like to give an introduction to it and why I posted that, and I'll list the recommendations here, which are tentative. I don't personally care about any particular ones of those. I just want to open a conversation because it's important that we sort of agree of like on how to do DS automation, and I'll tell you why. So the CDNS key automation is defined as in a bunch of RFCs, and it's quite precise in how it works technically in terms of like what's in the record type and the R data and so on and so forth, but it doesn't consider tangential topics like validity checks that the registry can perform. I mean, it says there are some, but you know, who knows which. It says nothing on error reporting. It says nothing on EPP logs, whether you should continue DS automation in that case or not. And because of these unclarities about those side topics, ICANN is currently not allowing the GTLD registries to perform DS automation. And actually some have tried, and one has actually also deployed it, and then they had to take it down because they realized, or ICANN.org at the time, maybe hadn't communicated clearly enough to the registry beforehand that it couldn't be done, and then they took it down again. But the point is there's interest amongst GTLD registries, but there's currently no way of doing it because ICANN says, and it does make sense, we need to operate, we need to interoperate, and we need to have no surprises for domain owners that have, I don't know, example.com and example.net, for example. And so that's why there's a list of issues they would like to see uniformly consensus style addressed before they will allow it. I think it would be good if the GTLDs were allowed to do it. And in a way, it's an ICANN policy issue, but never mind that. I think we can think about how it should be done ideally and then have consensus about that. So this is the list of operational considerations that need to be resolved according to ICANN, more or less. I'll skip over that mainly. You can click on the SAC 126 report on the top right if you have the slides open to read that in detail. This is a report from the SSAC at ICANN, and it has all kinds of stuff in it. That's why I'm showing this. And I will now go over the recommendations. There's 5 sections or something that have recommendations on different subtopics. And I'll just read them out here to make you guys aware and give some context about the rationale, but not completely, because that would be much more than 15 minutes. So you can either read that up or we can discuss it later. And again, this is not something that I think necessarily should be done like this. It's just a proposal. And I would like to identify in the session or later on the list, what are the contentious ones so that we can focus on working out the ones we don't have agreement on. Okay, so the first one is about validity checks and safety measures. That's what the parent registry or registrar does in terms of verification that things make sense when they process a CDS or CDNS key record. And it says here that the parent should apply essentially what's in the CDS consistency draft that is currently in the RFC editor queue to make sense, to make sure that the CDS and CDNS key records found in different authoritative servers for the same delegation actually agree. Because if they don't agree, then it's unclear what the intent of the registrant actually is. And then the same requirement 1B as in RFC 7344, which is you shouldn't deploy it if it breaks the chain of trust. Okay, fair. The second recommendation is intended to enable more quick rollback when you make a mistake, or even to make operators of large critical sites feel comfortable enough to actually give it a shot and not say, oh, we will never do DNSSEC because we can't roll back in a day or something because that's the DSTTL. So there's a proposal that originally was from Victor Duchovny, which says that when the parent updates the DS record set, then perhaps put the TTL down to, I don't know, 15 minutes, so you can easily roll it back and it disappears more quickly from caches. And then after some time, a day or whatever, or when you resign the zone anyway, you can ramp it up to the usual time again. And so there was a study shown, I think, at DNSOP last year or something, where Peter Spacek and somebody else showed that this recommendation is not expected to cause any noticeable increased load on TLD servers. The second section is on reporting and transparency. So it says sometimes for some DS updates, you should inform the relevant points of contact. So what is that? That's a good question I think we could discuss. Certainly it's not always the domain owner, and certainly you don't need to do notifications for everything. Maybe you want to notify someone when a DS record is first installed or if it is removed, but you don't necessarily, I guess, have to inform the registrant when there's an authenticated rollover with the CDS record. Then it says that when there are errors, you should attempt to contact the zone operator and not the registrant, and only when it persists for several days and it's not resolved, then you can involve the registrant. The third one is that notifications to humans should be done via email, and to operators should be done using a report query that works well together with the generalized notify. Oh, that's the one in the RFC editor queue, actually, not the CDS consistency draft I mentioned earlier. Anyway, so I think this one is contentious. .ch has pointed out that they implement much of this stuff, but not the email part, because they think it scales badly. If somebody has 500 domains with the same operator, they mess up, they get 500 mails. Fair enough. I don't know what's a good solution. Maybe we should talk about that. And then it says you shouldn't repeat the same notification too frequently. Okay. Then number 4 says when there's a registrar and a registry, the registrar usually will push updates to the registry anyway, so there is no extra notification needed to the registry to learn about that the DS record has changed. They know that anyway. But the other direction, if the registry does the automation, the registrar might not learn about it. So the registry should tell the registrar that something changed. There is an EPP extension to do that. And also, the domain owner should be able to look up the state of the DS record set in a web interface or something. So it shouldn't change automatically, and then the web interface should catch up, right, when it changes. Then this is an interesting one. So there's different types of locks. For example, there is what's called a registry lock. The EPP name of that is server update prohibited, and it says essentially when that is set, the registrar cannot affect any changes to the registration. So that protects against transfers, it protects against registrant name or like ownership changes, it protects against whatever change the registrar wants to make, so essentially against registrar compromise. Now, if the registry does the DS automation, should they be subject to this thing, which some people say should only protect against registrar compromise? So you could argue the registry can continue doing DS rollovers, for example. Or is the interpretation, if this is set, nothing should change at all at the registration level. So automation is suspended. It currently says to suspend it. Again, I don't feel strongly about it either way, but there is a fact that there are some ccTLDs already deploying DS automation, and some do it this way and some do it the other way. So I don't think this needs to be necessarily be reconciled amongst the ccTLDs. I think it's fine if they continue to behave differently, but the guidance that we publish for gTLDs that that I can will rely on in order to approve of this whole thing, that should have one position, so that there is one way of how we think it should be done for new deployments, at least, perhaps. Yeah, okay. Second part not so important. Then in more interesting cases when there are multiple submitting parties. So let's say there is a manual submission through the registrar's web interface, but there's also DS automation that that is taking place at the registry level, and the CDS record is published in the child zone, and then something happens manually also. How does that interact? Do you ignore one of them, or when, or why? And so what seems to be the case is that there is no reliable method to figure out which of those might be a mistake. And actually, there is no reason to assume that any of those are a mistake, because the thing that gets submitted in the web interface or some other channel, if it is authenticated at the time because the person was logged in and authorized to make the change, well, then apparently that's the current intent. And then if 10 minutes later, a CDS record is discovered and it is validly signed with a DS record that, sorry, with a key that was provisioned manually 10 minutes earlier, why not do the rollover if you discovered at the time? I'm not saying that you should check every 10 minutes, obviously, but if it's apparently authorized, I think second guessing the intentions is more difficult than just following. So it says when DS update requests are received, they should be executed immediately, whether they are received through EPP or another interface. Actually, it says interface, which I don't know what it is, but anyway, I had another thought. Yeah, so maybe one could combine this with reporting, right? Maybe if it changes twice in a day, you send some notification somewhere. I don't know, but I don't think it's a good idea to stop processing either of those. But one exception would be if the entire DS record set was removed manually through the web interface, for example, then probably the registrant doesn't want DNSSEC anymore. That's fine, and we shouldn't automatically reinstall it. So that's the exception listed in number 3. And yeah, then number 4, 5 is pretty much the same as earlier. And yeah, and number 6 says the registry should not do DS automation when it is known that the registrar doesn't support DNSSEC, because then the registrant has no web interface to turn it off if they want to. So they shouldn't be put in a position where they cannot handle it manually. I mean, it could break, I don't know, they could lose their key and then they don't have a way to manage that case. Okay, and I think the last one here is CDS versus CDNS key. I think this is probably an old discussion. I don't want to go into reasons why registries would prefer ingesting DS or DNS key format. In the latter case, you compute the the DS record on the parent level, and in the first case, it's computed by the submitter. The problem is that it's very difficult to change such decisions. Like if you are a registry and you say, we want CDNS key, not CDS, then you can never change that again, essentially, because your children might only publish that specific type. And I think it's a reasonable idea to keep open the possibility to reassess that decision and change it, and perhaps at some point get rid of one of the types, I don't know. And I think that can only be done if children are required to publish both of these types, and parents, when they see both, are required to check for consistency, which is the requirement we had earlier anyway. So in a sense, this is recommending a combined rollout of this, if you roll it out at all, of course, so that later it's okay to have a new recommendation that says, and now ignore CDNS key, for example, then everybody can just use CDS. And I don't know if this is a good idea. Again, it's open for discussion, but it is what's currently in the draft. So the final slide is, what of these are most contentious? Which of these? Then there was some discussion on the list, and I've put in some improvements already, which have been incorporated in what I just said. Unresolved suggestions so far are whether the acceptance checks that you run when you process CDS records or CDNS key should be run periodically to see whether the chain of trust still is valid, because it can break also on the child level. I think that's not the parent's task, but we can talk about it. And also then there's this question like, what's the alternative to email for notifications to a human? And somebody pointed out that the child zone operator could publish their communication preferences to solve that. And then we don't have to be opinionated about it, but then, you know, we need another protocol to sort of announce that stuff. So I'm a little hesitant about that. And then if you think this is interesting, there's, of course, a question for working group adoption, and that's all I got.
Go ahead, Stefan. We have only like a minute and a half, so please be quick. And the queue has been already locked. I'm sorry that there's not enough time for have a longer discussion.
Stefan Bartmeyer, AFNIC. There are in the draft things that are no-brainer. I mean, everybody will probably agree with the technical checks, but the rest is much more ambitious because it depends on registry policies. On the example of registry lock is a typical example because this is something that was never standardized and maybe should not be standardized. There have been several attempts and all fail. So what I would suggest is to change the draft to have two parts. One, which is technical checks that probably can we have a consensus on. And the rest of the draft should be, instead of a list of should, must, that will never get a consensus, to have a list of what you should document if you are a registry, in the spirit of policy statements and things like that. So this is a point that if you implement CDS, CDNS key, this is a sort of thing, this is a checklist that you have to check to be sure that your documentation covers everything.
Okay. Yeah. So outsourcing some of it into a DNSOP practice statement. Thank you.
Hi, this is Ulrich from ICANN. Yeah, so first I would say I would like the document to not name GTLDs or CCTLDs. It should be a recommendation for TLDs running this.
The document doesn't name them.
Yeah. So, yeah, and then I think the consistency part here is that, I mean, we already have guidance on this in the standard, and I think that is quite good. What we actually don't have guidance on is in the standard it says, well, you get a new DS record set and you switch it out to put away the older one and switch in the new one. But it doesn't say what if one of the DS records in the new set has a algorithm that is not supported by the registry, for example. So there is stuff that we need to discuss and that can be that I think we should clarify for the user. And then I think we should not call it registry lock, because as Stefan said, this is something that is, you know, highly undefined. But okay. I think in your draft, what you have is that you look at the EPP flags that are set. And that, I think, is a way forward, because you say, when this flag is set, we should do it. And when this flag is set, we don't do it. And we don't call it registry lock.
Okay, so the term registry lock is too policy loaded, but the EPP flag is not. So, okay, got it. There were a few other people in the list. I think we're out of time. So I don't know the names. I can't see it from here, but please post it on the list. I'd be very interested, or contact me otherwise. Thank you.
Yeah, please continue the discussion on the line, on the mailing list.
So next one, Gautam.
Clicker works, should work. Yeah.
Okay, awesome. My name is Gautam Akiwate, and today we're talking about a draft service binding mapping for background requests. It was originally called something else, but we had some great feedback on the mailing list, so we already have a major update. But the basic idea remains the same, and the need for the service binding parameter key still remains the same. So what are we trying to achieve? In the past week, let's say you're a weather application and you have had a bunch of IETFers frantically looking at their weather application trying to figure out if the weather is going to become cooler, or what time of the day is best to go out. Is it going to get cooler at some point of time? And it makes sense for the weather application to treat these requests as latency sensitive, as interactive requests, and serve these from the closest edge location. But it turns out for the majority of the time, the weather application is actually running in the background. And these, when the weather application is running in the background, it's still fetching a lot of data. It's making all of these requests, but in the background, just in the case that the user opens it, and so it has all of the data ready. And these requests that are happening in the background do not have the same latency requirements that the ones that are when the user is actually interacting with it. And essentially, what we would like to do is let the client utilize its local context with the help of the system. And if we can do that, then allow the client to optimistically choose or opportunistically choose send the background request to a different endpoint, which can help reduce costs. Okay, I was just confused because there are two different things happening. Okay, there we go. So the way we currently do this is we delineate tasks into background and interactive requests. So we have two different service endpoints.
Time is fixed. Sorry.
Okay. So we have two different service endpoints for different requests. And what we find is that having like the basic idea of having two different service endpoints is solid, but sort of having the application logic sort of take that into account, sort of kludgy. And what we would like is for a way to clients to dynamically discover these endpoints. So the goal of this draft is to allow clients to dynamically discover these service endpoints and for background requests specifically, and then utilize the local context with the help of the system to opportunistic choose cheaper and underutilized servers. So this could be something that is slightly cheaper service farther away, or an edge location in a time zone that's not being as heavily used. So the way we are going to do that, we already have a way for the clients to discover alternate endpoints, and we are essentially using the SVCB records. And specifically, what we are proposing is a new service parameter key called background priority. And roughly speaking, this is a way for authoritative name servers to signal that the endpoint is optimized for background requests. And this is essentially an opportunity for like authoritative name servers to play the latency price arbitrage. So the background priority of 1 will indicate that the endpoint is optimized for background requests. Here is an example of what an authoritative name server can send. So in the first record, we have an interactive .service.example with a background priority 0, and the background service.example has a background priority of 1. And keep in mind that the second record actually has a service priority of 2. So ideally, in our current definition of SVCB, it would only get used as a backup. But we'll see how this might change when we start incorporating the background priority. So the goal of this background priority parameter is to allow authoritative DNS servers to indicate which service endpoints are optimized for background or interactive requests. So now that the client actually has received these SVCB resource records with this background priority parameter, now the client needs to figure out if the request that it's dealing with is appropriate for background handling. And this can be done in a bunch of different ways. So for instance, the application can hint the system saying, oh, this is a background type request because I know like these are to some heavy-duty updates, or the system can utilize its context about the application, knows whether the application is in foreground, background. There are a bunch of different ways to do this. We don't specify how you find out, but let's say the client figures out that background handling is appropriate for the request. And if it is, then the client is going to filter down to records that are background priority equal to 1, which means that we are only left with one of the two. And even though the service priority for this endpoint is 2, we would still end up using background.service.example. So the current status, we have a test implementation. And in our current implementation, the way we allow applications to sort of signal that they are actually, that they want to have a background request handling is to mark it with the background traffic class. But as I said before, using traffic class is one approach. We can use a bunch of different approaches, and we intentionally do not specify how this signaling happens to the system. So with that.
Okay, thank you. We have a long list of people queuing for questions.
I don't know if that's a good thing or a bad thing.
Yeah, I think it's a good thing. But also a heads up, we only have 3 minutes. We will be very strict. So please be brief, and we will cut off the line, although you might be still before the lock.
Hi, Gautam. It's Joe Abley. The incentive for the person who's publishing the endpoint location of saying this should be used in the background is clear. But what incentive is there for a client to ever use the background?
Right.
Option.
So this is in when the client, the application, so the weather application and the server, so this is when both of them are being operated by the same party, right? So the weather application and the servers are being operated by the same people, so the client is incentivized to do that. And this is a way for the system to help facilitate that interaction in a way that allows them to dynamically discover. Okay. Perfect.
Hi, Ben Schwartz, Meta. I'm supportive of this draft. I just wanted to note that I have some outstanding feedback on the mailing list, so I think we should have some more conversation there. I'm not sure this is the perfect final design, but I think it's a good direction.
Thank you.
Thank
you for the initial feedback too.
Yeah, I think that the filtering seems very dangerous, an easy way to make your service unavailable accidentally.
Okay, we can talk offline.
Hi, it's Peter from DESEC. It's just a detail. The name of the parameter BG, priority, background priority, I find somewhat confusing. I mean, I can read that lower means higher priority. And so my problem with the term is you could think the higher the numbers, the more background style it is. But you could also think the higher the numbers, the higher the priority is because it's more reliable or something, or quicker. So I probably could read it and implement it. But for the benefit of those who don't read everything, I suggest thinking about a different term.
Naming is one of the harder things in computer science. So naming has been a problem. But we expected this to be a Boolean value. But I take your point. So if you have suggestions, we can talk offline and figure out what a good name could be. So, okay. Thank you.
So, Shimon? And next up is multiple algorithm rules in DNSSEC.
Okay, hi folks. I'm Shuman, and I'm going to talk about some proposed adjustments to the multiple algorithm rules in DNSSEC. Do I control the clicker?
Yeah.
All right, a little bit of background. This topic has generally been circulating for a while amongst a subset of the DNSOP crowd for going back several years. So back in 2022, I did a presentation where we proposed to relax some of the rules. to allow multi-signer configurations to work across providers that supported different signing algorithms. And as a corollary to that, to also allow the non-disruptive migration of a signed zone between providers that also supported disjoint algorithms. All right, so jumping into some details, RFC 4035 says that there must be a signature for each RR set using at least one DNS key of every algorithm in the DNS key RR set. In addition, the Apex DNS key RR set must also be signed by every algorithm that appears in the DS of the parent. And there are very good reasons for this rule, which Mark Andrews just reminded me of. We want to increase the success of validation across the population of resolvers, and also to prevent zones from being downgraded to insecure in the presence of an adversary that may be able to strip away known algorithms and leave only the unsupported algorithms. But our proposal was to just remove this restriction and simply rely on zone owners to take appropriate actions to guard against these scenarios. So for example, if you wanted to deploy a zone with multiple algorithms and still allow single algorithm signed responses at any given provider or server, you could do that. You just have to be very careful to choose only well-known, widely supported algorithms across the set. The second relevant rule is from RFC 6840, which says that validators should accept any single valid authentication path. They shouldn't insist that paths associated with every advertised algorithm work. And our proposal was to strengthen this language, to change all the shoulds to must and make it mandatory. And this is in fact how practically all validators in the field work today. The only known exceptions are there are some software that have knobs to override this behavior. So I think folks know, I'm looking at Benno here, Unbound famously has an option, harden algo downgrade, which if you turn it on, does insist that all algorithm paths should validate. And our advice is please don't use that option. That will cause problems in the field. And in fact, it has caused problems in the field when it was briefly turned on as the default in some prior version of Unbound. Okay, so in the intervening years, many detailed discussions on this topic have occurred amongst a subset of us, and a more nuanced proposal has emerged, which is documented in the current draft. And we now propose to selectively, rather than unilaterally, relax these restrictions in the presence of what we formally designate to be universal algorithms, which are essentially very widely known, well-supported algorithms, while still protecting against downgrade to insecure attacks for all but now deprecated algorithms. All right, so the set of use cases that we intend to support is also broadened a little bit. In my original conception, I was thinking mainly of the multi-signer use case and the provider transition use case, but now we're also considering the case of pre-publication of a trust anchor in preparation for an algorithm rollover, such as for the root zone, where it could avoid long periods of double signing and dealing with larger responses, which is known to have some negative operational consequences. There's also independently rolling the algorithm for a KSK or a ZSK, and also relieving the computational burden for online signers when they have to deal with multiple algorithms, such as when they have to do an algorithm rollover. So these are not just theoretical concerns. Real world scenarios have occurred which have caused problems. I already mentioned my case where I tried to deploy a multi-signer configuration across providers that supported a different algorithm, 8 versus 13. But more recently, you may remember that during the provider transition of the .gov TLD, something quite complicated had to happen. So one party had to implement the other party's signing algorithm. Then both parties had to carefully execute a multi-signer transition, followed by the gaining party then having to do an algorithm rollover. And this whole process took a very long time. I think it was like a year or so. And our feeling is this stuff There is no reason for this stuff to be so complicated. All right, this is the reason why DNSSEC is so hard and people struggle with it. Okay, so jumping into some more specifics of the nuance proposal, we have two new algorithm designations: universal, which I already hinted at, which is essentially very widely supported algorithms that are recommended for signing and validation. So currently in our proposal, the list includes 8 and 13. You could argue that maybe ED 25519, algorithm 15, should be included in that list, but those are just details we can hash out later. And there's another category which we denote formally universal. So these are algorithms that were once widely supported, but are now deprecated or have rapidly declining support. And concomitantly, we propose to extend the IANA DNSSEC algorithm numbers registry with another column to denote the status. So whether the algorithm is universal, formally universal, or neither of those things. All right, and we have some tweaks to both signers and validators. The tweak to the signer is that if the DSR set or the trust anchor set includes no universal algorithms or any formally universal algorithms, then the current rules apply. Signers must sign with every algorithm present. And otherwise, if universal algorithms are present, signers need to only sign with one of them. Other signatures of other algorithms are optional. And the proposed tweaks to the validator is if the DSRR set or the trust anchor set includes an unsupported formally universal algorithms, then validators need to treat that zone as unsigned. And this is essentially to deal with situations like the one caused by Red Hat 9's sudden invalidation of SHA-1 algorithms, which caused some problems in the field, right? So we want those situations to kind of gracefully degrade to insecure without causing serve fails. So absent that, validators just do what they do now, which is they accept any valid single viable path, only it's a must, not a should. All right, so I'm just showing one example of a configuration that is now, that would be formally sanctioned with these protocol rule adjustments. I won't go into the details, you can look them up yourselves. But the one remark I want to make is these kind of configurations, you can actually deploy them in the field today if you're using authoritative server software or signer software that allows you to relax the signing constraints. So I have certainly deployed this kind of stuff in the field with my own custom software, and it basically works with all validators. And with that, I'm going to stop and entertain comments or questions. Joe.
Hello, Joe Abley. This is not actually a comment on your proposal, which I think is probably fine, but just a small comment. The transition for the .gov registry did take a long time, but I think that's mainly to do with a change of suppliers for a government agency taking a long time. The actual transition didn't take much time.
Okay.
And it was multi-signer, and it worked very well because of all the work you've done. So it's a good use case for that, but I wouldn't say that's a good example of why this can take a year.
Got it. Okay, thank you, Joe.
Mark Andrews, I dislike this intensely. We then we'll have arguments all the time about what is universally deployed.
Right.
You have upgrading of validators all the time to work out what is universally deployed, what isn't universally deployed. If it's universally deployed, why aren't the operators of the signers deploying the universally deployed algorithms?
Right.
And as for the Red Hat just watched the removal of the thing. That was not graceful. They did not do a graceful shutout. They broke the app. They broke the validators by breaking the OpenSSL implementation in their release. So that is not a reason for doing anything like this. As a developer, we had to fix that by finding out whether these algorithms actually worked at runtime. It wasn't detectable at compile time. I don't see the need for this. We have, as you said, for the Gov, Operators can deploy algorithms. They can quite easily roll up the other one. If it's universally deployed, if it's a universal algorithm, why haven't they deployed software that supports it? They may have their preferred algorithm, but for rolling, they can quite easily turn it on. It's a matter of turning on and turning off. That is a business decision. This shouldn't be a product. We shouldn't make our protocol less strong because operators make bad business decisions.
Yeah, I mean, point taken, Mark. So the DNS protocol does have to deal with the real world of what's actually deployed, right? And operators making decisions. So that's one of the reasons we need to do this kind of things. And on your point about Red Hat, I totally agree. They did the wrong thing, right?
Yeah, Jim Reed. I have to say, Mark's pretty much said everything that I wanted to say here. Frankly, Sherman, I think the idea of adding another category into the ANAD registry for these algorithms to say universally deployed or formally universally deployed just opens up a rat's snake of complications and confusion. You know, if someone's looking at this from a point of view of deploying, validating resolver, or actually writing software for this, do they or do they not use something which is considered universal because of a status bit in the IANA registry? Surely the criteria is this algorithm is deprecated or this algorithm should be used. I don't think we need to complicate it any further than that. Thanks.
Okay. Noted, Jim. That's it, I guess.
Oh, Philip.
Yeah, so I strongly support this document with one exception. I don't like the validator part at all. Mark already described why the whole Red Hat thing is completely wrong, so I'll leave that out. Why I think this is important is that if a validator sees a DS record and it has an algorithm that it understands, then we have the basic requirement on the signer that the validator can also find a suitable ZSK in the DNS key RR set to validate the signatures in the zone. And then if all the algorithms need to be the same, then this will obviously work. But what we would like to have is a case where we can have an algorithm in the DS that is different from the algorithm with which the zone is signed. And there's many reasons for that that you listed, like multi-signer, key roles, and all that stuff. So that's why I think this is an important thing to have. And we can only do this if we say these algorithms are so widely supported that we can assume that if the DS points to one algorithm, then the validator will also support the algorithm because we just know that. But I think that we can leave out the requirements on the validator. I think validators should not do anything else. And so the formally, thingy should just go, and we should have one label and it says, well, these are very well-known algorithms and signers could play a game with that if they want to.
Yeah. Okay, great. Thank you for your comment, Philip. I think, yeah, I'm on your side about maybe we don't need the tweak to the validator except strengthening the should to must. The accommodations for the Red Hat situation, arguably, we shouldn't make protocol changes for that. But yep.
And Victor, we have like 30 seconds, so please be brief.
Sure. Just a quick comment. Universal really is universal in resolvers. It's not universal in signers. We're asking the question of, is this understood by validators checking the records? And in terms of the relaxation for the formerly universal, that's actually necessary because otherwise a signer that signs only with a formerly universal algorithm can cause the zone to be bogus. And so we do need the validator that's decided that an algorithm is now deprecated to be handled correctly.
Okay.
Thank you. Thanks. Next up is Ben remotely.
Okay, next slide. Oh, okay.
Sorry, I pass control to you.
Great,
Is this
thank
fine?
you. Yep. Hello. Okay. This is going. We're going to keep this brief. Okay. Sometimes you have to debug DNS systems. You end up with questions or like just network systems in general. Like, is the network even working? Like, I'm trying to ping stuff, but I'm not getting anything back. Is the network down? Is it an ICMP black hole? Is my DNS server broken? And so there's a bunch of debugging questions that we use all the time. And there are also these more systematic profiling questions. I've been configured with some DNS resolver. Does it do DOT? I have a bunch of different resolver IPs that I could use. Which one is closest? I have a fleet of resolvers, the thousands of machines. What is the total overall availability of this fleet from a particular vantage point? But we often confront these kinds of questions. So show of hands, and have you ever run one of these commands or basically some moral equivalent of these commands, right? I think chances are a lot of us have done something like one of these. And we're not alone. Here's Cloudflare Radar showing that example.com is one of the top 200 domains globally. I don't think that's because of its compelling content. So the goal of this draft is basically to see if we can do better than example.com for this stuff. We need it like example.com. We want a domain that makes it clear what we're doing. Basically, so the server log clearly show this is a reachability probe. But there's no need for iterative resolution in most of these use cases. We're just trying to check if we can reach the resolver. We don't actually need anything in the response. And we don't want to get a false positive or negative based on potentially an outage or problem upstream at the authoritative server. We're just trying to check if we can reach the resolver. Also, if you do a probe like this to a domain that's specific to your client, then you identify your client, which is a potential privacy concern. So the proposal in this draft is to declare that the name for this purpose is probe.resolver.arpa. Resolver.arpa is already designated as a locally served zone. So probe.resolver.arpa is already a locally served NX domain, which is fine. We just need some response. And if you don't implement the locally served zone, then you'll still get NX domain. And you'll forward to the .arpa name servers, which is probably as good as we can do in terms of reliability and lack of commercial infrastructure dependencies and all that kind of stuff. Okay, does it actually work? So I tested, my team tested this at scale. We compared answers for probing www.google.com versus probe.resolver.arpa from a lot of vantage points using different protocols. They fail and succeed in the same ways at the same rates. The latencies are very closely correlated. Actually, probe.resolver.arpa is a little faster, which is probably in general a good thing. Because it's not asking the resolver to do any work. So there's some details about this, about things like, what if you want to use getattr info for this? Or what if you want to use, should you use DNSSEC? No. There are some questions for the group. And this is currently seeking adoption. I would say the argument for adoption here is subtle, but it's something like, if we're promising that this is always going to be NX domain, then that's actually a standards action. It binds the IETF going forward. Okay, the end. We have 1 minute left.
Thank you. Yeah, 1 minute for one question. Tobias, run.
Tobias Hiebig, Max Planck Institute for Informatics. That's why I have a ThinkPad. And my concern is that we did have before things in local resolution where we put things into .arpa. I think Prev 64 discovery was there as well. And I'm not so sure whether that is so sensible and whether it captures all use cases. I, for example, when hitting dig against local resolvers, want to know whether they do things to IPv4 addresses in answers. That would, of course, not be possible with the hard-coded NX domain. So I'm not so sure whether this covers all use cases and if it might not actually hit some issues we had before in other domains.
Sure. So I'd love to know what more about those. Maybe you can follow up and share
true.
some of that, the examples of issues that you hit there. I don't think the goal here is to learn details about the behavior of the resolver. That information would be with probably via a mechanism like resinfo on resolver.arpa. If you want the more detailed information and aren't just checking if the resolver is running at all.
I'll go to the ML.
Thanks. Now, Joe is going nowhere.
Okay. Hello. Oh, good. All right. I've got far too many slides, so I'm going to talk to this one, and then Wes has got some new stuff at the end, and I'm going to talk about that. And all the stuff in the middle is just for the archive or anybody who's reading ahead. So I'll talk briefly about this. This is the general situation in which this zone cut to nowhere might be helpful. So on the left, you've got a client, it's the general internet, it's out in the world, it's looking up a name, and that's the namespace. It goes corp.example exists, but stuff below it doesn't exist. But in a different namespace, in an internal campus network namespace or something, there's actually more of it that exists. You've got an internal part that exists. So the reason for calling this corp.example is to illustrate this is supposed to be a general mechanism, but it came out of the various conversations around .internal, and I think it would also be applicable to .internal. So we can do this today. There's nothing new here. But at the moment, if I'm in the global namespace and I'm a mobile device and I look up www.internal.corp.example, I might get a cryptographically signed proof of non-existence of that name, which I could then cache. And then if I move into an internal namespace, now there's ambiguity because now my local name servers are saying that this thing does exist. But previously I've been told cryptographically it doesn't exist. And now we've got an area where we're asking either you should ignore the cryptography, which seems bad, or you should have special local configuration, which seems difficult, and maybe there's a better way. So the better way, skip, is to have a zone cut to nowhere, which is in the public namespace. You specify a delegation, but you don't specify what servers can use it. So you don't say the name doesn't exist, but you make it impossible in the global namespace for the name to be resolved. So you never get a proof that the name doesn't exist, but you also don't get the stuff that shouldn't be available because you're not in the internal network. So we can do this already. We can just specify a name that doesn't exist, but when we have conversations about what name should we use, then that tends to extend to infinity, and we never end up with a name that anybody likes. So the idea was just don't specify a name, just specify the empty name. So it turns out that using the empty name, which you would represent just as dot, has been used before. It's been used as an MX target to mean this host does not accept mail, don't bother trying, MX something dot. SRV specifies you can use an empty target, which means this service doesn't exist. SVCB allows you to specify a dot, meaning the service is not available. So we do have some existing use of this. There's obviously some concern that maybe this affects the root zone. Maybe some naive client will try and look up an Apex A record for the root Apex, and maybe that will cause a problem. But I suppose the reason for mentioning these other things is if it was a big problem, presumably we'd know about it. It doesn't seem to be a big problem, but Wes, who I think is Wes in the room? Very good. So if any questions, Wes can answer these. Wes did a bunch of science, and he did a small amount of science to start with, just so we could have a slide. This is not a fully developed piece of science, but he didn't find any obvious reasons why this is going to cause an explosion. So to the left of the green line, we see some examples of delegations being followed through a bunch of Atlas probes with the usual sort of mess of results, because lots of the world does weird things and the DNS is filled with dragons and bits of filth. And to the right of the green line, we've got examples where there's actually a delegation to nowhere, and that delegation to nowhere looks like mostly it does what you'd expect, which is a serve fail. Because when you have a delegation to a name you can't resolve, you expect a serve fail. And in fact, that's what we see. And we didn't see any infinite loops or spikes of traffic or anything else like that. So the news for this little presentation is that Wes did a little bit of science. Probably some more science will happen. But the natural curiosity about this, will this hurt the root servers? The answer seems to be no. And that's it. So the question for the room, hopefully we've got time for someone to express an opinion, is what should we do with this? Is this worth adopting just to annoy Andre because he doesn't like it apparently?
No, I'm just saying that we don't have the time.
Oh, we don't have the time for a question.
Like there's a 15 seconds. So Mark, can you make it in 15 seconds?
Mark Andrews, I think this is dangerous, especially for resolvers in dealing with chains of forwarders and things like that. We've got other mechanisms that work for most of what that work well for what you've got, and just setting low TTLs on what gets returned works. So NS to the same set of name servers with a dname into empty to empty gets you the traffic there. The only thing different is you've got a DS record potentially.
So it seems like
the delegation.
We could have a conversation about this on the list, and it seems like that would be a good conversation. Thank you.
Thank you. Yeah. So just for explanation, we have 5 minutes presentations, and the main reason is to get discussion on the mailing list. But it's good to have to put it on stage also.
Okay.
Yes, I'm waiting. Synchronizing caches of DNS resolvers. Oh. So the goal of this work is to create a way to, or standardize a way to share cache entries between a network of cooperating and mutually trusting DNS resolvers. Why? Decrease the latency between the stubs and the resolvers, decrease traffic to the authoritative name servers, less work for the resolvers, less work for the authoritatives, less traffic on the network, so less energy spent, which could make it greener. And how this is different from earlier cache sharing approaches, not by having a cache database backend of some sort, but instead by distributing resolution results to the other resolvers in the mutually trusted set. And this way it's also easier to standardize between different implementations. So how does that look? So suppose we have resolvers at the top of an Anycast network. If step queries one of the resolvers in the set, if it has the response in cache, it just answers immediately, of course. But if it has not, then it starts working on the query until it's done working, and then stores the response in its own cache, answers the stub, and sends the response to the other resolvers in the mutually trusting set. So that if one of the other resolvers will get the same query, they will be able to answer immediately from cache. So how is it distributed to the other resolvers? Just as a DNS response, maybe TSEC signed, maybe over a multicast network to also reduce that amount of traffic. So this also has potential for follow-up improvements, protocol improvements. For example, this is a real-world example of one of such resolvers on a POP in an Anycast network of Quad 9, to be precise, which had to reboot because of a software update or something else. And so it lost all its cache entries, and it took more than 8 hours to get the cache hot again. So the protocol would at least provide a way to quickly fill the cache again. It could be extended maybe by, if a resolver is rebooted and wakes up, hey, I have nothing, could you get me up to date quickly? Then, responses could be sent with a mechanism T6 signed, and the cache could be filled quickly. So the current co-authors is a nice mix of operators and open source resolver implementers, among which of the operators one Anycast resolver operator, which is nice. I worked on this during the hackathon, and I made really good progress, though it's not completely finished yet with Unbound. But you can expect the workable implementation to be there soon. So how about it? Good idea, bad idea? Are you, the working group, interested in working on this?
Peter?
Hi, Peter. So I'm not so much of a resolver person, so maybe I didn't get it right. So if I understood correctly, the resolver that benefits from this receives such copies of responses whenever another peer resolver gets a response, and then it gets forwarded, right?
Yeah.
So how does that help with the 8-hour cache warm-up? Because let's say I reboot, I have an empty cache, and I listen to such copies from my other peer resolvers. Yes. I would not get their full cache copy, right? I would only get it when they have an entry expiring and then requery that. So that would be maybe, I guess it would be a little steeper in the beginning, but the tail would end after 8 hours anyway. So wouldn't it be
it's
more...
a follow-up work, but it's at least it sets, the first step is set for that second use case.
Okay. Why don't you store the cache before rebooting?
Yeah, of course. But maybe there's a crash, or or the computer, the power outage, or something.
Hi, Shane Kerr. So this is a really interesting idea. I wonder, I haven't read the draft. What's the target? Is this intended for people running cooperating servers in a cluster, or is the intention for a wider scale cache sharing?
No, I think it's scoped currently for resolver operators that run resolvers in a cluster, yeah.
Okay.
So there are significant complications to this model because of ECS, right? Not all cache entries are necessarily applicable to all clients. There may also need to be complicated interactions with the DNSSEC validation status of the cache entry. Is it one of these cache entries that's subject to a CD flag and wasn't validated, or is validated, and then the zone status may change to previously signed to now signed, and so on. I think it's a complex topic, and just a naive send only the response loses a lot of context.
Yes, so that's why, as the example, I gave the POP, one of the POPs, so it's local of our Anycast network and not the complete Anycast network. Actually, I think, so this would be work items of this document, of course, but I've given it some thought, and I think if there's a ECS in the response, then it's actually safe to send it to other locations as well. But yeah, those are work items for this document, definitely.
Okay. Since we still have a little bit of time, I'm going to channel what Patrick said on the mailing list. For the measurements, it would be interesting to see like hit miss ratio on these things in the cache, because most of the cache is just like garbage. So it takes 8 hours to fill the cache with garbage, but how quickly does it fill with useful stuff? So
yep.
If you do the measurements.
Yeah, but also I think those kind of issues are the same with implementations that have a shared cache back-end database. You know, this is not different, except that you can use multiple implementations to do the same.
Okay, thank you.
Yep.
Next up is Johan.
So, can you hear me? Yes. I have two drafts here, and I will spend a small amount of time on the first one and slightly more time on the second one. And the first one, I also want to add to some sort of competition for smallest, simplest draft. So this is about... Oh,
It's lagging.
it's lagging.
Yeah.
Okay, so it's a hard lag, so it's a question of waiting.
So on the second screen, it's up to date, and for this screen, there's a lag, but it seems to.
Yeah. Okay. So there is something called the generalized notifications draft, which is presently in the RFC editor queue. We shouldn't touch that one. These days, it takes a long time to get out of that queue. However, perhaps there were a couple of things we didn't think about. So this is how a normal desync record looks. We say essentially that there is a receiver service for a notification at port at target. And we use that to be able to say, if I change my CDS, I could just notify the parent and they will look at this quickly. So that's great. However, did we miss something? Perhaps we did. The first thing we may have missed is that there are things that actually scan stuff, but they don't operate a receiver today, and they have no intention of operating a receiver tomorrow. They are just scanning. And I happen to work for one of the organizations that do such scanning, and one of the things that happens repeatedly is that people contact us and they say, oh, I updated my CDS and I know that you have a scanner, and why the fuck are you not looking for it? And we say that, well, we have a scanner, but it doesn't run all the time. So this is a mechanism by which we could potentially say, okay, there's no notification receiver, that's the dot. That's sort of similar to the delegation to nowhere stuff. We use a dot to say there is nothing here. But then we reuse the port number to signal the frequency of the scanner. So that's something that you could do, we could do tomorrow in Sweden, for instance, in spite of not yet having a receiver. There's no implementation here. It's just policy. You just add this record and you say, I happen to have a scanner. It runs this often. Done. Sort of useful. I mean, if everyone runs a receiver, we don't need this, but presumably there are people running scanners with no receivers, at least now. So that's one of them. The other one, what if there is no scanner at all? Today, we cannot state that in any way. So people publish CDS records and they hope that the parent has a scanner. Well, most parents don't, so there's not much to hope for. But in the future, perhaps there will be more scanners, God forbid, but it could happen. And then we now have the option of authoritatively state, there is no scanner here, move along. So the reason for the draft is essentially that because the generalized notifications haven't been published yet, at some point it will be published, hopefully quite soon, and then hopefully some people will implement it, and then it would be useful if they also took this stuff into account. It's not meant to change any software. It's only meant to provide a signal to the operator that the reason why nothing has happened may be because of this. So it's a small thing, but if we want it to happen, we should sort of take care of it before the other draft is actually becoming an RFC. And that's about it. Yes.
Liman, you want to take it now?
Sure.
Yeah.
Hi, Lars-Johan Lehmann, at the back to your right. Just one small question. I'm in favor of all this, except the timer interpretation. Please make it seconds. Every other bloody timer is in seconds. Please make this one be that too.
We can discuss that, but we don't have an infinite number of bits because this is a port number.
Okay, I see.
So point taken, we can talk about it, but we didn't choose minutes just to annoy you.
Okay, fair enough.
Well, perhaps we did, but not only because of that.
Any more questions? No.
Hello. What if the scanner is not right here, down here? What if the scanner is not the parent, but your registrar?
Yeah, that's very, very true. So I sort of skipped over that part. It's important that this is only a statement of policy, essentially, on the parent side, saying, I do not run a scanner, or I run a scanner with this frequency. In the particular case, and if you look at bullet number 3 there, if it is a registry that has registrars, the registrar could be running a scanner. I absolutely agree with this. And then it would be sort of counterproductive to say that the scanner runs this frequently or it doesn't exist at all, whatever. But it wouldn't change anything, because this is only about signaling to the human operator that the reason nothing is happening is because you should still publish your CDS record. You should still do the same things in software.
Right.
The point is well taken, but it's meant to be safe.
Yeah, okay. So if only some registrars scan, then there will not be a negative signal, and then you know nothing.
Yeah, exactly.
Okay, got it.
Yeah.
So it's a little bit up to you. You have to manage your time. There's 9 minutes. You can go to the next presentation,
Yeah,
ask for feedback for both.
I'll go to the next presentation.
Yeah, okay.
And I will speak to Joe later.
Okay.
So next presentation, opportunistic DNS transport signaling. This is, let's say, this is a known problem. We've been talking about this for years. Why don't we have more authoritative DNS traffic go over DOT or DOQ, etc.? And there are 2 known paths forward that are already sort of on the way. One is RFC 9539, which is blind probing. We have no clue whether the server supports DOQ or not, but let's try it. The other one is obviously DELEG that will solve this at some point. My only concern with DELEG is the delay until we have it. Otherwise, I'm sure it will be fine. And I think privacy is sort of important. So I'm not sure I want to wait that long. I think we should possibly do what we can before that, preferably in a way that makes it easy to upgrade to DELEG once it's ready. So what about 3595 then? Sorry, 9539. Well, it just tries, and if it gets a live one on port 853 and a response of a quick happiness, and we can use it. It isn't much used yet. Some operator is doing it proactively, and perhaps that will expand, and I'm hoping it will expand, but it's sort of in the early days so far. So the question now is, can we somehow change the incentive a bit to make this more likely to happen within the current protocol waiting for DELEG? So this is essentially about, could we improve on 9539 easily? And here is our proposal. It's not exactly a new idea, but it's an idea worth using. Especially it's worth using because we're reusing the DELEG transport signaling mechanism, but outside DELEG. So the idea is that you add a new SVCB record to the additional section, and that essentially contains an ALPN equals transport that I like, said by the authoritative server. So the authoritative server is saying something, is making a statement on its own behalf. And then obviously the resolver may or may not act on that. It may or may not choose to upgrade transport, etc. That's entirely up to the resolver. Noticing the hint or not, noticing the hint but not acting on the hint or not, etc. It's resolver side choice. So how does this look? We have a resolver. The resolver sends a query to ns.provider.example. ns.provider.example notices that I'm actually in the NSRR set of the zone from which I'm generating the response. And because of that, I add this opportunistic transport signal. And if provider.example is assigned zone, there will also be an RRSig so that this is actually possible to validate in spite of the, let's call it the customer zone, in this case axfr.net, not being signed. So we can have a signed hint even though the zone for which the hint is given is not signed. Why do I think this is good? Well, I think it's good because it's very simple. It's extremely simple to implement in the authoritative server end. It doesn't touch the ecosystem, so to speak. It has nothing to do with the registrant-registrar-registry relationship. It doesn't touch EPP. It doesn't touch the parent at all. And it only touches the child zone in the special case of, let's call it a vanity name server, where the child uses a provider of some sort, but they want to have the name of the name server be child.example because that looks cool. We can deal with that also by actually adding the SVCP to the child zone, but that's the only case when we actually attach that zone at all. There is a slightly more complication or complexity in implementing this in the resolver end. There's no denying that. On the other hand, it isn't wasted effort because this is exactly the same stuff that we will need to implement for DLEG regardless. So we're sort of taking a piece, a specific piece of future resolver complexity from DLEG and make it possible to start playing with this already. And then when DLEG comes around, we get the transport signal there, and it will be the same thing in the resolver end. However, there are a couple of other things to consider here. And among them, one of the things that I really don't like with 9539, the blind probing one, is that there is no way of distinguishing between testing our DOQ ability and announcing DOQ as a service. So if I turn on DOQ on my name server and one of these blind probers come around and, oh, that guy is running quick, and suddenly I, in the future, may get a lot of traffic over quick, which I may not be quite ready for because I'm still testing this. I have concerns about the operational impact, etc. So from that point of view, it makes a lot of sense to be able to turn on quick support or DOT support, play with it, test it, make sure it works nicely. And when I'm sure it works nicely, I add a transport signal, which is essentially a statement saying, this is now ready for use. And I must have a signal to be able to signal. Otherwise, it's blind. So that's a very, to me, very important distinction between blind probing and having a signal. So I'm all in favor of the signal from DLEG. I'm all in favor of having a signal pre-DLEG. The other thing is that while this is opportunistic, so it could be stripped away, we cannot depend on it being available. If I have a signal, I can upgrade the signal. That means that I could, as a resolver, explicitly ask for the SVCP, including the RRSig, being able to validate it, etc. So if we like this, it's possible to make it stricter, so to speak. We don't have to start there, and I'm happy already with the opportunistic part, but we could decide to upgrade this in the future. And the downside is essentially opportunistic and not secure, which is what we have today. To solve those things, we will have to wait for DELEG. And that's it. Questions? I can't see who it is.
Back. Yeah.
So
Be us, but we have 30 seconds.
We can also just take it to the mailing list. I think that might be better, or just try to find you during the break.
Okay.
Ben?
Hi, Ben Schwartz. So we have RFC 9461, which defines the service binding mapping for DNS. It does not use the word resolver anywhere. It is generic for any use of the DNS protocol, regardless of whether you're setting the RD bit or not. So you can do this 100% within RFC 9461 today. And as far as I know, authoritative servers are within their right to throw whatever additional records they think are interesting in the additional section. So I think that this is all basically allowed and defined today, if you really want to do it. Whether we should do it, I think, depends on whether DELEG is actually going to align with this. So I think we actually need to wait for DELEG. And then if we've waited for DELEG, we don't need this. So I don't actually see a need to do a lot of standardization here. But if you want to experiment with it, I think that's fine.
I think we are mostly in agreement here. I mean, in the end, DELEG is a good solution. The only question here is how long will we have to wait, and how many trillions of queries will go in clear text until then. So yes, and I know this is within the protocol, so we can do this now.
Okay, final. It's yeah, Victor.
Yes, I think you were indicating that this new service B record would be signed. Yes.
Yes.
So this applies only to in-bailiwick delegations?
No, it applies to any delegation, but if the name server providing the response has, well, if the name of the name server providing the response is in a signed zone, then presumably the SVCB will be signed, and then you will return the RRC together with the SVCB.
This is a delegation from a parent who's delegating the zone the name server is in, so the parent can't sign names under the name server name.
This has nothing to do with the parent. This is completely not anything to do with the parent. This is only about a hint provided by the authoritative name server for the child. So it's not the same as the DELEG approach, which is...
so this is on the second line. So you discover the child, then you talk to them, and only then do you discover their transports.
Exactly.
Step 2, okay. Understood.
So yes, the first query to a name server you never talked to before will be over UDP. And the next 5 million queries could be over QUIC or TLS or whatever you want. Okay, thank you.
Okay. Thank you. This concludes this session. Everyone have a safe trip home. See you next time.